Hello guys, today we're going to the 2025 AMC10B Problem 6. So the line y equals 1/3 x plus 1 divides the square region by 0 less than or equal to x less than or equal to 2 and 0 less than or equal to y less than or equal to 2 in the upper region and lower region. The line x equals a divides the lower region into two regions equal area. Then a is equal to square root s minus t. What is s plus t? So our graph kind of looks like this. This is line 1/3 x plus 1 right here. And basically we can calculate the area of the top by extending it where x equals 3. So then we have 1/3 by similar triangles, 1 and 2. So the area of the big thing is 3/2, and the area of the small thing is 1/6. So this is going to be 8/6 or 4/3. So we know that the top half is 4/3. So the bottom half is 8/3 because of 12/3 minus 4/3. So you'll want to find a line. We want to find a line here that separates this into area 4/3. Alright, so how do we do that? So let's draw this line here, A. Since the slope of this is 1/3, we know that this y level is 1/3, as the slope of this is 1/3. So now we have 1 here. So by the area of a trapezoid, we have 1 plus 1 plus a over 3 times a over 2 is equal to 4/3. So this is equal to 6 plus a times a is equal to 8. So a squared plus 6a minus 8 is equal to 0. A is equal to negative 6 plus 36 plus 32 all over 2. And so since this is 68, which is 4 times 17, this gives us root 17 minus 3. And so 17 plus 3 is equal to 20.
Today we're going to be working through the 2025 AMC10B Problem 7. So Francis stands 15 meters directly south of a locked gate in a fence that runs east-west. Immediately behind the fence is a box of chocolates located X meters east of the locked gate. An unlocked gate lies 9 meters east of the box, and another unlocked gate lies 8 meters west of the locked gate. Francis can reach the box by walking toward an unlocked gate, passing through it, and walking toward the box. It happens that the total distance Francis would travel is the same via either unlocked gate. What is the value of x? Well, we have a lot of information coming at us right now, so let's draw what's happening. So we have Francis here, and he is 15 meters away from a locked gate. And it runs east-west. Yep. And immediately behind the fence is a box of chocolates X meters east of the locked gate. So this is X and this is the chocolate. Let's mark it with a star so we know this is what we want to get to. And an unlocked gate lies 9 meters east of the box. So we have an unlocked gate that we can pass through. And on the west of the locked gate, there's another unlocked gate. And this is 8. So we want Francis to walk to an unlocked gate and then go to the chocolates. And the path between each of these sides is equal. And we know this is also 9, by the way. So we want Francis to walk to the unlocked gate on either side. And we know that the path that he can take would be equal. So if we use Pythagorean theorem, we know right here is an 8 and that's a 15. So if we use Pythagorean theorem, the hypotenuse here, because he stands directly here, that's a right angle, we know this value is 17 meters. So the path Francis would take if he went to this unlocked gate would be 17 plus 8 plus x, and that would get him to the chocolate. And this is equal to the path we take on this side plus 9. So how long is the path we take on this side? Well, we can also use Pythagorean theorem. This whole length right here is x plus 9. So the path would be the square root of x plus 9 squared plus 15 squared, and you have to plus 9 to get to the chocolates. And let's simplify this a little bit. We have 25 plus x on this side, and if we square both the values here, we have x squared plus 18x plus 81 plus 225 plus 9 is equal to that. Now let's square both sides to get rid of this square root. But we can move this 9 to the other side to keep it simple. So we have 16 plus x is equal to this square root thing. Now let's square both sides. If we square 16 plus x, we have 256 plus 32x plus x squared. And if we square the square root, you just get x squared plus 18x plus 81 plus 225, and if we add that out, that is 306. Perfect. Now we notice you can cross out the x squareds because they're on both sides, so we just have 256 plus 32x is equal to 18x plus 306. So if we subtract, we have 14x is equal to, what do we get on this side? We have 50. So x is equal to 50 over 14. You can divide by 2 on both top and bottom, so we get 25 over 7. And if we put this as a mixed number, we get 3 and 4 over 7. And that's our answer, which is answer choice C.
Moving on to the 2025 AMC10B Problem 8. So Emmy says to Max, I ordered 36 Math Club sweatshirts today. Max asks how much did each shirt cost. Emmy responds, I'll give you a hint. The total cost was ABB.BA, where A and B are digits and A is not equal to 0. After a pause, Max says that was a good price. What is A plus B? So let's take this into place value. This is 101 cent times A plus $11.10 times B. Let's multiply by 100. Multiplying by 100 won't affect if it's divisible by 36 or not. So you want to take this mod 36. So a 10,001 is 29 mod 36, and 111 is equal to 30 mod 36. And this is pretty easy just by dividing and finding the remainder. We want this to be equal to 0 mod 36. To make these numbers more favorable, let's change them to -7 and -6 respectively, and add them to the other side. So now we have 6b plus 7a is equal to 0 mod 6. So from here, 36. So from here, you can just guess and check, but one that works is a equals 6 and b equals 5. And so from here, our answer is 11. Thank you for watching. If you enjoyed this video, make sure to like and subscribe. Peace. Hello guys, so you're on the 2025 AMC10B Problem 9. How many order triples of integers x, y, z satisfy the following system of inequalities? Alright, so first of all, let's just transform the first equation to a more favorable term. Okay, so let me just rewrite all the equations here as for easy use. So let's do casework. Case 1, z is equal to 0. If z is equal to 0, then we have x plus y is greater than or equal to 2. Y is less than or equal to 2 plus x. X is less than or equal to 2 plus y. And then x plus y is less than or equal to 2. This means that x plus y is equal to 2. So now we have 0, 2, 1, 1, and 2, 0 for a total of 3 numbers. Case 2, z is equal to 1. If z is equal to 1, then we have x plus y is greater than or equal to 1. Y is less than or equal to x plus 1. X is less than or equal to y plus 1. And x plus y is less than or equal to 3. So here we can have 1, 0, 2, 0, 3, 0, 1, 1, 2, 1, 1, 2, and 0, 3. But there is a caveat. We know that x must be less than or equal to y plus 1. So 3, 0 won't work, and 2, 0 won't work either. And similarly, we have oh wait, I did forget some here. Similarly, we have that. And yes, now we only have 5 left. And so our last case is z is equal to 2. This means that x plus y is greater than or equal to 0, y is less than or equal to x is less than or equal to y, x is less than or equal to y, and x plus y is less than or equal to 4. This means that x is equal to y, so we have 0, 0, 1, 1, and 2, 2, which is 3 cases. So our total is 3 plus 5 plus 3, which is going to equal 11 cases. Thank you guys for watching. If you enjoyed this video,
So let f of n equals n cubed minus 5n squared plus 2n plus 8, and let g of n equal n cubed minus 6n squared plus 5n plus 12. What is the sum of all integer values of n for which f of n over g of n is also an integer? So let's write out what we have here. So we know n cubed minus fn squared plus 2n plus 8 over n cubed minus 6n squared plus 5n plus 12. So that's what we're trying to find, and we want integer values that will make this work. So let's see. Say we want to simplify this problem to make it easier to solve. So let's first take the bottom to simplify. So we have n cubed minus 6n squared plus 5n plus 12, and we want to simplify this. Well, notice the coefficient of n squared is negative 6, so we can try using the completing the square method. So if we have n cubed minus 6n squared, and let's have this be 9n. So we have to minus 4n, so we can keep the same 5n. So if we factor this out, let's take an n out of this. So n times n squared minus 6n plus 9 minus 4n plus 12. So it's n times n minus 3 times n minus 3. And notice we can factor a negative 4 out of this. So we have negative 4 n minus 3. And this will, if we combine these, we will get n minus 3 times n minus 4 times n plus 1. So that's what we have for our bottom. But now let's take a look at the top. Let's take what we have here and bring it down. So we want to simplify this too. Well, what's one way we can simplify it? Let's try to get some of the same terms so we can cancel out some things. Well, if we take this, we can section it into n cubed minus 5n squared plus 4n minus 2n plus 8. So that's what we have for the value on top. Well, now we want to find so it has some of the same values. Well, we could also take this to get n cubed minus 4n squared plus 4n minus n squared minus 2n plus 8. You can really just try to go about this by trial and erroring, trying to find and notice different factorization patterns. So if we take this, we have n times n squared minus 4n plus 4 minus n squared minus 2n plus 8. And we know this value here is n minus 2 times n minus 2. And that on the other side factors out to be n plus 4 times n minus 2. So now if we combine it, we have n minus 2 times n squared minus 2n minus 2 minus 4. And we can factorize this out too. Oh, this is an n, by the way. And if we factor that out, we have n minus 2 times n minus 4 times n plus 1. And that's what we have on the top. So let's take what we have at the bottom here, and let's take it down also. Put it right here. And now it's pretty easy. We can notice that these cancel. So we have n minus 2 over n minus 3. Now we want to find what values of n would make this an integer. Well, if you notice, if we take n is 2, then 2 minus 2 is 0, and 2 minus 3 is negative 1. So it's equal to 0, and 0 is an integer. Another case that would work would be if n is equal to 4. Then the top is 2 and the bottom is 1, and this is equal to 2. Now, this is the case that n equals 2, and this is the case that n equals 4. Now, let's put it back into our original equations just to make sure they work out. So if we put n is equal to 2 into f of n, we have a minus 4 times 5, which is 20, plus 4 plus 8, and that's equal to, we have 12 here, 12 plus 8, which is actually 0. So sure, that works for the top, but now let's try g of n. We really want to test g of n because we don't want to have g of n is equal to 0, because that would make this not doable because we can't have a 0 in the denominator. So let's plug 2 into g of n. So we have 8 minus 4 times 6, which is 24, plus 10 plus 12. This is equal to 22. 22 plus 8 is 30, so this is equal to 6. So perfect, it does work. But now let's plug in n is equal to 4 into this. Well, if we take a look here, 4 cubed would be 64. 4 squared is 16. 16 times 6 is 96, plus 4 times just 20, plus 12. 20 plus 12 is 32. 32 is 96. So 96 minus 96 is 0. So in this case, it'd be 0 on the bottom. So that doesn't work. So our only value of n that would make this an integer would be 2. Answer choice A.